Hey there, this is Math 7, Unit 3, Lesson 9, Applying Area of Circles. And we're going to find the areas of shapes made up of circles today. And one of the things that does come up in today's lesson, just to have it in your mind, is the phrase, in terms of pi. Okay? That means that sometimes we just leave our answer with the pi thing in it, and we don't use the 3.14 or the 22/7 to figure out what pi would actually be. Sometimes we just leave it with a pi. You might get an answer that's like 7 pi or something like that, and that's okay. We can just leave it like that. It helps us kind of group things together a little bit. And so today in today's lesson, you will do a couple things where you leave things in what we call terms of pi. Okay? So it does come up in the homework, and there's not much in the lesson there, so keep that in mind. First of all, number one, or lesson activity 1, still irrigating the field. So here we have that same field from last time. Last time we talked about it, we estimated its length to be somewhere around 500, I remember from last lesson, 500,000 square meters was what we did in our last lesson. Okay, so here's what that one looked like over here from last time. If you recall from lesson 8, we did this here. We said it's about 800 by 800 with 640, and the best approximation would be somewhere in between 500,000. So here we are again, still irrigating the field, and we know it's somewhere around 500,000 meters squared. What's the field's area to the nearest square meter? Assume that the side lengths of the square are exactly 800. So to find the area to the nearest square meter, now we have to do a little bit more math here, don't we? Okay, so it depends on what units you use for pi to help you figure this out. Okay, so for example, I know that the distance across the entire thing is going to be, in this case here, 800. Well, half of that distance then, or my radius, would actually be 400 meters there. That becomes my radius value. So when I look at this problem, I know that to find the area so far, we've said we're going to use pi times the radius squared. So it depends on what I use for pi. Pi times 400 squared, that's where I'm at so far. 400 squared is equal to 160,000. So I have 160,000 times pi. And this is where it becomes important to decide what do you want to use for pi. Okay, if I do 160,000 times 3.14, what I end up with is 160, 123, times 3.14. I end up with 502,400, and that is choice A. That works out, no problem, right there, looks great. Okay, if I do 160,000 times, and I press my pi button, I end up with, so 160, 123 times my pi button, I end up with 502,654. And when we look over here, that's pretty much this one, choice C. Okay, so I end up somewhere between 502 and 502,655. Okay, this is when pi is just 3.14, and this is when it goes out a few more, 3.1415, a little further out. So the more precise I am with pi, the more precise my answer is going to be. So if you use 3.14, you'd get that. If I use my pi button, I would get that one. I probably wouldn't get these other ones though. This is larger than pi. So the most accurate answers are going to be A and C for this first chunk right there. Now let's look at activity number 2. For activity number 2, it says that each square has side lengths of 12 units. So this whole length here is going to be 12. The length there would be 12. The length here would be 12. And it says to compare the areas of the shaded regions in the 3 figures. Which figure has the largest shaded region? Okay, well let's figure out what the shaded region is going to be. First of all, the shaded region is what's left when I look at having 144 for the whole area of the square is 144, because 12 times 12 is 144. So that's the whole square. So if I take out the circle part, that will tell me what's left. Well, this circle, because the length is 12, has a radius of 6. Okay, so for my pi r squared, for my area of the circle, pi r squared, I would do 36 times pi because 6 times 6 is 36, and that would give me about 113.09 for the area of the circle right there. Okay? This circle right here has a length of, if this is 6 right there, that's 6. Now I'm chopping this in half to get a radius. If that was 6, that makes my radius equal to 3. Because I go 3 plus another 3 is 6, plus another 3 is 9, plus another 3 is 12, right? So my radius is 3. With this radius, I do pi r squared, and that becomes r squared is 3 times 3 is 9. So we have 9 times pi, and 9 times pi is 113.09. That sure does look familiar, doesn't it? Sure does. Let's take a look at this guy right here. Here I break it up, and again 12, so I have three parts here, which means the length of each one is going to be 4, 4, and 4 for my diameter, because 4 plus 4 plus 4 is 12. And if that's 4, that makes my radius, the short part, equal to 2. So we have pi r squared. Oh, I got to back up over here. This is not 113 right away. Sorry, let me back up. So sorry, guys. That becomes 28.27, but there are 4 of them. So sorry about that. There are 4 of them, 1, 2, 3, 4. Now 28.27 times 4 is equal to 113.09. That's what matches there. Sorry, sometimes I get a little ahead of myself. So in this case here, I'll do pi r squared, and my r is 2, so pi times 2 squared, which would be 4 pi, and 4 pi is 12.56. But again, like with B, there are 9 of these things though. So 9 times 12.56 is again equal to 113.09. So I have all of these circles all add up to be the same space. So the big circle is equal to the 4 circles, which is equal to the 9 circles. If those are all the same, that means the shaded area is also going to be the same. So my shaded area's value is going to be 144, the whole square, minus 113.09. And when we do the math there, what we come up with is 30.91 in all of our sets. It's going to be how much shaded space that there is. Okay, so it's interesting to think about that. Even though it looks like I have more circles, which I do have more circles, the amount of gray space or shaded area remains the same. This amount is the same as here and all these other ones combined as well. Kind of cool. Let's take a look at number 2 with this first this activity. It says each square in figure D and E has a side length of 1. Alright, so it has a 1 and 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 a 1. Okay? Compare the area of the two figures. Which figure has more area? Well, I know that this square has an area of 1. That square has an area of 1. Here I have a square with a 1 and a 1 and a 1 and a 1. No problem there. But I also have, in this case here, I have a half a circle and another half a circle. So this is going to be one whole circle there, right? There's one circle, and here's another circle right there, those two together. Over here, I have a quarter and a quarter and a quarter and a quarter. That's going to equal one circle, and then I have those, which is going to be half a circle. So I have one circle, and I have half of another circle, right there. Over here, I have 2 circles, and then I have 2 squares. Now for these circles here, because it has a length of 1 on that square, that means that my radius is equal to 1. My radius equals 1. Same for over here. This radius is going to equal 1. My radius equals 1. So the area of one of these circles is pi r squared. Okay? My 1 times 1 squared is 1. So I have 1 times 3.14. So the area of one circle is equal to 3.14. In this case, I have one circle, 2 circles. So I have 2 circles so far. There's 1 and there's 2. And then when I look over here, I have a square, which has an area of 1, and another square, which has an area of 1. And so when I add those up, I have 3 plus 3 is 6, 7, 8. So I have 8.28 for the area of that shape right there. Over here, I have 1, 2, 3, 4. Okay, that's a given. And for the circle, I have one circle which is 3.14 again because the radius squared times pi is going to be 3.14 times 1 squared, so that's that one. But I also have half of that circle. So I need to do 3.14 divided by 2. And 3.14 divided by 2 is equal to 1.57. If you weren't sure, you could again just take your calculator and do 3.14 and divide it by 2, and we get 1.57. So now I can combine all of these lengths here, and 7 plus 4 is 11, carry the 1, we have a 7 there, decimal drops down, and we have 8.71 here. Okay, so those are the areas of my two shapes so far. The question though is which figure has more area? We would say that E is the larger of the one because it's 8.7 compared to 8.28. How much more? Well, then we would do subtraction. 8.71 minus 8.28, and when we subtract, we end up with 0.43 units more is how much larger this one is compared to that one. So using what we know about finding the area of circles and squares, we can compare different shapes of different sizes, ones that are made with different types of circles and half circles. So it's kind of neat there to take a look at that. So that becomes our how much more is 0.43. Okay, so that's what you did on that activity right there. Let's take a look at the next one. Okay. In terms of the are you ready for more, I'm not going to go through this there. Could you figure out which one has a longer perimeter? You certainly could. You can go back and do the same idea, use the same picture to figure out the length around those shapes and compare the perimeter differences there. Let's take a look at the running track again. We've done this before. This was an optional activity, so you might have done this in class or maybe not. But it's a good little question to consider. It says the field inside a running track is made up of a rectangle 84.39 meters long and 70 meters wide, together with a half circle at each end. The lanes are 9.76 meters wide all the way around. What is the area of the running track that goes around the field? So what we're asking about here is what's the area of this part? That's what we're wanting to find out. What is this part there, the actual track? So if we don't include the grass area in the inside of the track, we're just talking about the space where the runners run, what is that area right there is the question they're asking you to solve. Okay, so we really need to break this up into a couple different chunks. We really do. First chunk you might want to look at is this chunk right there as a little rectangle piece, okay, which we can duplicate right there. We have it twice, here and here. We can find the area of that rectangle piece pretty easily, right? That's going to be the base, 84.39, times the height, which in this case is 9.76, right? And so that is our height there for what we have for our straightaways. And so 84.39 times 9.76. Oops, 84 point, oops, hit the wrong button. 84.39 times 9.76 is going to give me 823.6464, and there are two of those, right? So we take that amount there and we multiply it by 2 times 2, and we end up with 1,647.2928. Okay, so that's the area of what we would call our straightaways, right? Those are the two straightaways on the front side and the back side of the track. Okay, that's part of it. But now I need to figure out the area of this part right there. This is a little more complicated. The area of a circle is going to be pi r squared. We know that much so far. Pi r squared is the area of a circle. But I have a couple things, right? I have a large circle, and then I have a small circle on the inside. If I can find the area of the large and I could subtract the area of the small, then I would find out that space right there. Okay? So to do that here, I need to find out the radius of the large and the small small circle. Okay. So the radius of the small circle, let's do the small one. I had a diameter of 73, which makes my radius equal to half that. So 73 divided by 2 is going to be 36.5. Okay? So for the small circle, what I would do is I would say, let's do pi times 36.5 squared. So 36.5 squared is going to be equal to 1,332, and we multiply that by pi, and we end up with 4,185.38. That's the area of the small circle. The area of the large circle, though, a little different here. My diameter is not just 73. My diameter is going to be 73 plus the added 9.76 here and the added 9.76 there. 73 plus those parts right there. All of that together, 73 plus 9.76 plus 9.76 is going to be a diameter equal to 92.52. That will make my radius half of that. So my radius is 46.26. And again, I'm going to then find the area. I'll do pi times 46.26 squared. And when I multiply that, 0.26, I get that times pi, and I end up with 6,722.96. And we'll stop there. Again, the area is going to be, though, of this part on the outside, the large number minus a small number. So let's do our large number, 6,722.96, and we'll subtract that 4185.38. And what we have on the outside of the track, okay, is going to be 2537.58. So the question, though, is asking about all the yellow. So this gives me the curve here, as well as the curve over there. So now I have my two straightaways and I have my two curves. So when I combine all these together, 1647.29 and 2537.58, that will be my total. 14 carry the 1, 8, and 11, and we have 4,184.87 meters squared becomes our combined area for this track. A long problem with lots of steps, all of which you can do. You just really need to take your time to process and think through, what is it asking me to do? Draw some pictures, break it up into chunks and help you figure that out, and really take your time to work it out. What can be tricky sometimes is you might make a computational error, which I do all the time, and so it's good to go back and double check your work to see how you're doing and if you got that right. Check with a partner and see what they got. Your answer should be pretty close. Again, you might have some variance in your final answer right around the little parts because of what you used for pi. If you use your button for pi, or if you did 3.14, that could change a little bit of what you have for a solution, but you should be pretty much near 4,184 for your actual final answer. So in summary, we said that a relationship between A, the area of a circle, and R, its radius, is A area equals pi r squared. Okay, so we're just landing on that finally there. What's interesting here to think about, which we didn't cover, but is important to know, is that you can also figure out the fraction of a circle as well. If we look at a circle like this, if we notice that we have 1/3 of it used, I can also use that 1/3 to help me figure out what a fractional portion of that circle is going to be, and I can do that no matter what. And I also can remember, we talked about at the beginning, I can leave things in terms of pi. So instead of plugging in that 3.14, I could just leave it as a pi thing and leave it like that. Okay, so that's going to come up in your homework as well. So let's take a look at that. Okay, so here's our homework for the day. It says first, a circle with a 12-inch diameter is folded in half and then fold it in half again, what is the area of the resulting shape? Okay. All right, so we have a circle. All right, if I take a circle and I fold it in half, then what I'm left with is just half of that circle. If I fold that in half, then I'm left with just half of that circle. So in all, I'm only going to have about 1/4 of the circle. Okay, so that's what I need to think about here. For my diameter was 12. That makes my radius half of that. Half of 12 is going to be 6. So to find the area of that space right there, I want 1/4 of the area of the circle, which is pi times the radius 6 squared. Okay, well, 6 squared is 36, so we have 36 times 1/4 times a pi, and 36 times 1/4 is going to be, so at 36 divided by 4, it's going to be 9, so that becomes 9 pi. And if we were going to leave it in terms of pi, I could stop right there. But it doesn't say to do that, so I'll do 9 times pi, and I end up with 28.27, okay, for what my solution would be there. So the area of this is going to be 28.27 inches squared, for the area of 1/4 of a circle with a 12-inch diameter. Number 2, find the area of the shaded region and express your answer in terms of pi. That means we're going to leave the pi in our answer and not worry about the 3.14. Okay, so we're looking for the shaded region. So the shaded region is going to be the whole thing minus all these other chunks. So the whole thing is, first of all, it's an 18 by, in this case we have 12 plus 9 plus 6 plus 3. Okay, so 12 plus 9 is 21, plus 9 more is 30. So it's an 18 by 30 shaded region. 18 by 30 is going to be 540. So we know that the shaded region is 540, and now I want to subtract from that all the circles. Okay, so my answer is going to be 540 minus all the circles. All right, let's find the circles. If this is 6, that makes the radius here 3. If this is 9, my radius here is 4.5. If this is 12, my radius here would be 6. Okay, so let's find out the area of each of these here. This becomes pi r squared, so 3 squared. This becomes pi times 4.5 squared. And this is pi times 6 squared. Okay, so 3 squared is 9, so this becomes 9 pi. 4.5 squared is 20.25 pi, again leaving in terms of pi, and 6 squared is 36 pi. So now I can add up 36 plus 20.5 plus 9, and that's going to add up to 65.25, and we just keep our pi like that. So for a solution, we would say it's going to be 540, the area of the whole shaded area, minus the area of those circles combined in terms of pi. So that's the area of the shaded region in terms of pi. Yep, it's not a totally done answer, but that's just what they want you to do. Okay, it's the whole minus the circles combined. Number 3, the face of a clock has a circumference of 63. All right, so we have our clock, and the circumference is 63 inches. What is the area of the face of the clock? Remember, circumference is found by doing 2 pi r or pi d, however you want to think about that. To find the area, we know we need a radius, don't we? So I'm going to use 2 pi r for now. We're going to set this equal to 63 equals 2 times 3.14 times r to solve for r. To solve for r, I'm going to take 63 and I'm going to divide it by 2, moving the 2 over there to get 31.5. And then I'm going to do 31.5 and I'm going to divide that by 3.14. Okay, and I end up with 10.03 is my radius. Something like that, 10.03. Okay, so now for my area is going to be pi times 10.03 squared will be my area. So 10.03 10.03 times 10.03 equals 100.6, right? So 100.6 times pi, and if I multiply that by my pi number, I end up with about 316.04 inches squared. That's about what I get. So 316 is probably just fine for an approximate value there as well. Okay, number 4. Which of these pairs of quantities are proportional to each other? For the quantities that are proportional, what is the constant of proportionality? Remember, constant proportionality means that we have x equals k times, y equals k times an x value. So we have a y equals k times x type of idea, where this number is going to be our constant proportionality and there's nothing else added there. Radius and diameter, we've said before that makes a proportional relationship between a radius and a diameter. That the diameter is going to be 2 times the radius. Okay? Our k value in this case is going to be 2, because our diameter is 2 times whatever the radius is going to be. For the radius and circumference of a circle, the circumference is always equal to 2 times pi times the radius. So in this case here, our k value is actually going to be 2 pi. That's the amount that's going to be our constant throughout the whole thing, 2 pi. The radius and area of a circle. Area, remember, area is going to be equal to pi times r squared, right? It might be tempting to think, well, that's a k value, and it could be, except that we have that 2 right there. And so as a result of that squared, this is not proportional. Okay? Now in terms of the next one, we have a diameter and circumference of a circle. Well, our diameter and circumference work like this. Circumference equals pi times the diameter. So our k, our constant in this case, would actually be pi. That's the value that's going to stay the same. And for diameter and area of a circle, area equals pi r squared. Well, area is pi r squared. Because we have that squared part there, I really can't put those together. We would say not proportional as well. Okay. Number 5. Great question for number 5. Find the area of this shape in 2 different ways. So one way you might do it is we could enclose this and have one whole rectangle, which is a 4 by 3. Okay, so 4 times 3 is 12, and then we need to subtract minus that triangle part right there. Well, the triangle in this case is 1/2 of the base. If that's 1, this is 2. 1/2 of the base times the height, which is also 2. So 2 times 2 is 4, divided by 2 is 2, and we could say that it's going to be equal to 10 meters squared. So that's one way. Okay. Another way could be that you just do it like this. Well, let's do another way. Another way could be we say, well, let's use a line there. Okay. And again, this is a 1, and if that's 2, that makes this 2, and that makes this a 2, and that a 3, and that makes this a 2, and that is still a 2. So now we can look at some different values and say, well, 1 times 2 is 2, 2 times 3 is 6, and over here 1/2 of 2 times 2 is going to be 4 over 2, which is 2. So now another way could be to say, let's take the triangle plus the skinny rectangle plus the fat one on the bottom, and we do 2 plus 2 plus 6, and we have 10 meters squared. So a couple ways of doing that there. One, taking the whole and subtracting the little piece, or taking all the whole piece and chunking the 3 little parts there. All right, and our last one. It says Elena and Jada both read at a constant rate, but Elena reads more slowly. For every 4 pages that Elena can read, Jada can read 5. Complete the table. Well, here's our table on the next page for our last one today. Okay, and like always, tables are very helpful. We can think about it as an x and y, and so in terms of that rate she's reading, it's the y over x, which is 5 to 4, is what we're talking about here. So I can use that as my constant proportionality So then multiply. So 5 over 4 becomes 5 over 4. 9 times 5 over 4 becomes 45 over 4. S times 5 over 4 becomes 5 over 4s. And now these ones, to go the other way, I'm going to multiply by the reciprocal, right? We flip that over, go the other way. So I can reduce this to 1 and 3. 4 times 3 is 12. And again, multiply the reciprocal, we get 4/5 times j. Okay? So this is the review from Unit 2, Lesson 5. So here's an equation for the table. J equals 1.25 E. Okay, so here's Jada, J, and E. Where'd that 1.25 come from? Well, 5 over 4 is also 1.25. That's just the decimal notation for that fractional component. That's where that came from. So what does the 1.25 mean? That means that for every one page that Elena reads, Jada reads 1.25 pages. So every time Elena reads one page, Jada reads 1.25 pages. Okay? Write an equation for this relationship that starts with E. So we're going to go the other way. Okay, that's the reciprocal thing, right? So if we already had J equals, think of it this way, if we had J equals 5/4 E, the reciprocal becomes E equals 4/5 J. Okay? And that's how the fractions make it a little bit nicer. If I wanted to use decimal form, I could say E equals 0.8 J, because 4 divided by 5 is 8/10 like that. So either one is okay. All right, that's it for today. Have a great one.